ahead and go over these answers now. I hit record. Let me just double check. So N2H4, what do we do to get the empirical formula?
Divide by 2.
The empirical formula here is N1H2. No. What about C8H18? Divide each of these by 2. C4H9 is the simplest ratio of those elements that keeps the mass percentages the same. Benzene. Benzene. C6H6.
Divide by 6.
Divide each of these by 6. You get C1H. You don't have to write the ones. You could write CH. That will be fine. Ammonia. Correct. Because what's not written to you is that that's a 1, right? So N1H3, the number in common is 1. It stays the same, which is why sometimes it's important to just have that one there, just to recognize that. All right, that's what an empirical formula is. It's just the simplest ratio between the atoms in a molecule. When you are asked to predict its empirical formulas, you will likely be asked to predict this for covalent compounds and more often organic compounds and not ionic compounds. And the reason why you wouldn't be asked to predict the empirical formula for an ionic compound is because you can always predict the formula for an ionic compound from the charges, whereas covalent compounds can combine in a plethora of ways. For example, C4H4 is a thing. C6H6 is a thing. There are multiple compounds that can have the same empirical formula with covalent compounds, but not with ionic compounds. So that's why you'll mostly be asked this for covalent compounds. I think we can do this now before we move forward. We had answered this question, the top one, before we left. Let's take a look at this question before we get started with the empirical formula process. It tells us that we have some random element Z. So let's read it closely. We don't know about it. We got some random element Z. And it reacts with chlorine to form a compound that has the empirical formula Z1Cl2. I'm writing this on purpose. We've got Z1Cl2. That means for every one of whatever element Z is, there are 2 chlorines. They also give you a little bit more information. They tell you that 31.13% of the compound is Z, and 68.87% of the compound is Cl. The question is, could you come up with a method to figure out the atomic mass of Z from this information? Is this enough information to come up with the atomic mass? Let's think about it. What could we do? What? What would we do? Is right? We're looking for, we want to know, what is this molar mass, right? What is the AR? What is molar mass of Z? Do we have enough information to figure that out? The information that they provided us in the question is that there's 2 chlorines for every 1 Z. And the other piece of information we've been given is that the mass percent is 31.13 grams of Z whenever we have 68.87 grams of chlorine. What could we do? This is technically something that, and I've seen a couple different questions like this before, that they're asking you to try to figure it out. Is there any type of relationship you could make that would make sense? Go ahead.
There's Z.
You do. So one of the ideas, so from here we would know, we know that the molar mass of the chlorine here is 71, right? That's what you said. But we don't know this, because we don't know what Z is. But we have another relationship. We know that because these are mass percentages, these are based off of grams. Mass percentages are based off of grams. That means whenever I have 68.87 grams of chlorine, I have 31.13 grams of Z.
Okay,
So what can we do?
Could look at the second row of the atomic. I mean the second row. The periodic table and just test with a few
Go ahead.
elements.
Not in the second row.
How do you make it?
Total, it doesn't add in the second row. It doesn't name, but
It's ZCl2, so it has to have two atoms.
Yeah, because you have to think.
Two electrons.
You have to think a little bit deeper for
So
this.
it could be magnesium or calcium. Or strontium.
So I'm going to go ahead and go over what you do.
Then if it's not calcium, it's strontium.
The best way to solve this, and just see if you get the same answer, is to make a proportion. Meaning, it is. Meaning that we know, and I would put one column for Z and one column for chlorine. We know that the mass of zinc is 31.13 when chlorine is 68.87. We know that that's true. When I have 68.87 grams of chlorine, I have 31.13 grams of zinc. Does that make sense so far? Because they have to add up to 100%. And so on the top, I would put my percentages. On the bottom, I would relate their atomic masses. So on the bottom, I would relate their MRs. Do I know the MR for either of them? The relative molecular mass. I know it for chlorine. I know that it is
71.
71. So the question is asking in a very convoluted manner, what is the relative mass of whatever Z is? And so we would call this our X or our unknown. So far so good? So I basically have to make a relationship that makes sense. I know that when I have 68.87 grams of chlorine, that I have 31.13 grams of zinc. When I have 71 grams of chlorine, I have how many grams of zinc? And now your answer, Hakeem, makes total sense, right? It's going to be, because 71 is just slightly more than 68.87, so your answer is going to be slightly more than 31.13. Cross multiply is the way you talk. Go ahead, Hakeem.
What I did was divide, say, 1 by 0.6887, and then subtract that from 71.
Let's see if we get the same thing. 68.87, and I get,
No, 0.6887.
but I'm going over how I related it, how I made the proportion. So you did the same thing, but with change the decimal. It'll give you the same answer because your proportion will be the same. 32.1 should be the answer. Is that what you all get? Could we have, for another point, ask what element this
Is
is?
it
32.1. So we're relating the mass percentages to the molar masses. That's what we're doing here. Because the mass percentages would relate to the molar masses. What element is this?
Sulfur.
So they could have for a third mark, they didn't here, but they could have for a third mark followed up and asked what element this is. It is definitely sulfur. Z is sulfur. And the question is, does that make sense? Is SCl2 a thing that exists?
Yes. Sulfur.
Can you make that exist?
Sulfur, network.
Is that a thing that exists? Well, let's think about it. Sulfur has how many valence electrons? Chlorine has? Does that work out?
Yes.
That totally works out with octet rule. It totally exists. Covalent compound. We didn't say it was ionic, right? It's a thing. So yeah, there we go. Makes sense. So this is an example of a question that, what level would we say this is? Definitely more in the level 2 range. This is a harder question than what I gave you in the bell work. Because you had to make some kind of relationship, some kind of proportion that makes sense. You had to use reasoning to figure out the answer. Relating the masses of the elements to the mass percents of the elements to figure out what unknown you have. You would always have only one unknown part. The rest you should know. All right. There will be a question like this in your homework, I believe. So make sure you have this written down. There should be a question like this in your homework. Yes. It is the weighted average. We did this last class. I had written this out, but it's the weighted average of atoms of an element based off of what? Unified atomic mass unit, or you could say 1/12 of carbon 12. The new terminology, though, is unified atomic mass unit. Yes. Is anybody tacky today? I think it's just Ben. It's just Ben. Go to the side. Yes. The 8.87. Yeah, I did. No, it's this. And then I cross multiplied. Yeah, but it's on both sides on the bottom. Because I divided by what is next to the variable because that's algebra. This is a multiplication, so I have to do a division. That's why. All right. So that was technically a question that we could have went over, but I wanted to at least teach what an empirical formula was first before we went over it. We could have technically went over it last class. We were also running out of time. That's why I didn't. So we're going to go ahead now to go over how to calculate an empirical formula. This is something that is in the standards for pre-ACE chemistry. It's also in the standards for ACE chemistry. So you may or may not recognize this process. Let's see. How do we find the empirical formulas from mass or mass percents? So if I have the grams of an element, or I have the mass percent of an element, how do I find the simplest ratio of atoms? There are specific steps you have to follow. You have to memorize these steps. And they are the same every single time. The first step is you figure out what the mass of each element in your compound is. If it's a mass percent, you change the percentages to grams. That's how I said it before. Change percent to grams because they're based off of 100 grams when you have a mass percentage. That's the reason why. Then, once you have the mass, you have to divide by the AR. Why do we do that? Because that gets us to moles. So once you have the grams, you have to change the grams to moles. You do this quickly by dividing by the molar mass, or the atomic mass, we now call it. Then, you may recall, you have to divide by the smallest number. Because you get some weird decimal. And you can't compare amounts in decimals. You have to use whole numbers. So the reason you do this is to get to a whole number. So divide by the smallest number. And then sometimes, if you didn't get a whole number at that point, you have to multiply to get a whole number ratio. Now, maybe this sounds like gibberish. We're going to follow the steps as we do problems. And hopefully it'll start ringing a bell on what we used to do here. All right, so change percentage to grams, change grams to moles, divide by the smallest number. They are the same steps every time. Let's take a look at a question from the textbook first before we look at any Cambridge questions. The composition by mass of a hydrocarbon is 10% hydrogen and 90% carbon. Deduce the empirical formula. So in this first question, I'm going to go step by step. What is step one?
Find the empirical formula mass.
To find the empirical formula, we first find the mass. We've been given percentages, so what's the mass of each element?
The mass of carbon is 12 and the mass of hydrogen is 1.
We've got 10 grams of hydrogen, and we've got 90 grams of carbon. That's where we would start. So the first step is to change percentage to grams. If you're given the mass, you got to figure out a way to get to grams. What's the goal of an empirical formula? Just because it'll help us track how we do our steps. Oh, by the way, hydrocarbon. You recognize what that is? That's organic. What's a hydrocarbon?
It's a molecule with only hydrogen and carbon.
Right. It looks like this always. That's a hydrocarbon, right? It means that it has to have just carbons and hydrogen. Okay. And X and Y are amounts. Grams are not amounts of particles. Grams are weight, they're masses. So what do we have to do now for step 2?
Divide the molecular mass by the empirical formula mass.
So change grams to
Moles.
moles. That's the simple to remember thing. So for hydrogen, I'm going to take 10 grams and divide by. So for hydrogen, it's going to be 10 grams divided by the molar mass of hydrogen, which is
1.
1, which gives me
10.
10. And for carbon, we know that that's 90 grams. What's the molar mass of carbon?
12.
And so 90 divided by 12 is
7.5.
7.5. That's 7.5. So far, so good? Technically, once you have moles, you have an amount. Moles are an amount. Just to be clear, they're an amount of particles. So technically, once I have the moles, I can put those numbers into the formula here, right? So I have C 7.5, H10. I know that when I have 7.5 moles of carbon, I have 10 moles of hydrogen. That's what we know. Now, is that an empirical formula right now?
No.
That's the ratio, but that's not the empirical formula. Because what's the definition of an empirical formula? It's got to be the simplest whole number ratio. So the whole point of step 3 is to try to get to whole numbers. And we do that by dividing by the smallest number. So step 3 is divide by the smallest number. Okay, what's the smallest number between 7.5 and 10? 7.5. So we divide them both by 7.5. And what does that give us? I know that this is C1, and then this is H, what, like 1.33? 1.33. Great question, Roslyn. In the empirical formula process, you should try to carry at least 3 significant figures throughout the whole process. If you round too much, this is where you could get into problems. So, we're here at step 3. Step 3 is where we could sometimes stop. If these are both whole numbers, we're done. Are these both whole numbers? We have to do step 4. Step 4 is to find some number that you can multiply both of these by to get them to a whole number. Do you remember what that was, what you had to do with that? We would find some kind of multiplier. I had written out, and I'm going to write them here. If you had an ending of 0.25, you would multiply by? So step 4 is optional. You don't always have to use it. But if you have, at the end of step 3, 0.25 at the end, you have to multiply everything by 4. If you have an ending of 0.33, you have to multiply everything by 3. If you have an ending of 0.5, you have to multiply everything by, and then you would see 0.66 or 0.67, somewhere around there, you would multiply also by 3, and then 0.75, you would multiply by 4. You should remember this. This is fractions. It's basically fractions. 0.33 is 1/3. That's why you're multiplying by 3. Write this down in case you need it. It's for the potential step 4. So at the question we're doing, what are we going to have to multiply by?
3.
And what I do to one element, I also have to do to the other to keep the ratio the same. So I'm just pausing to give you some time. Then we'll wrap up this first question. Is there? What did you do? So you're basically estimating numbers until you get to 90 and 10.
I mean, it's whole numbers, so it gets close pretty fast.
Yeah. Yep. So you multiply by 3 each of these, right? You get C, 1 times 3 is 3. And H, if you carry 3 significant figures, you get 1.33 times 3, which is 3.99. And so if you'll recall, can you round 3.99 to 4? Why or why not? Yes. Your answer here should be C3H4. And remember, as long as this is within 0.08 of the nearest whole number, that's where our cutoff is. Just in case you need to remember that. So if I end up with 3.99 at the end, I know that that can round to 4. If I had 3.95 at the end, could I round that to 4?
Yes.
Yes. If I had 3.95, could I also round that to 4?
Yes.
So within the 0.08. All right, so that's just the first example. We're going to, of course, work through this again. The next question, though, is from Cambridge. Can you figure this out? Do you have enough information? I'm pausing just a little bit longer, and then we're moving forward in about 20 seconds. Remember that we will be leaving shortly for a drill. Yes. A what? I probably do. After the drill, I'll give it to you. All right. Ready? All right. Let's take a look at the second question. In leaded petroleum with lead added to it, there is an additive composed of lead, carbon, and hydrogen only. You are told that this compound contains 29.7% carbon and 6.19% hydrogen by mass. Can you figure out the value of X in the empirical formula? See if you can follow through the steps and figure it out. I'm going to have you try this before I solve it. Remember, there are steps. If there are 3 elements and you've only been given 2 percentages, what would you do to find the missing percent?
Subtract.
Subtract these from 100. So to find the percentage of lead, you would do 100 minus 29.7 minus 6.19. So you should probably start there to find what is your percentage of lead. I'm giving you that as a heads up to help you get started. So 64.11. All right, see if you can figure it out. Let me know if you've got it by raising your hands. Raise your hand if you think you've got the answer. E3H4. Oh yeah, lots of fun. Remember, we're going out this way, back door. Go out the back door to the front of the school. Back door to the front of the school. Back door to the front of the school. I'm following. Welcome back. Welcome back. Welcome back. I'm really on it.
Yeah, okay. Yeah, okay, 64 is
We're double checking back. Everybody, please take a seat. Yes. What do you need? Oh, to check the answer? Okay. All right. Remember that. Let me just double check attendance. All right. So remember that until they call for the second drill, which I'm just going to double check everything now that it's locked. Until they call for the second drill, no bathroom breaks until after the lockdown drill has passed. Because it's usually right after. It's not very long from now, but it's usually close to after the first drill. So we want to make sure. When there's a lockdown drill, it locks lights out of sight, which means the windows are covered. However, if you would like to, you can move to the safety zone in the room. The safety zone in the room is back here behind this table. The lights will go off. I'm actually going to turn the back lights off now. And you can stay in the safety zone quiet, or you can stay at your desks because I do have the doors locked. The doors and covered, they're covered. So that's you. You do have to stay quiet during a lockdown drill. Completely quiet. And then I'll turn the lithium board off and the rest of the lights off when the lockdown drill begins. I am going to check for those who would like me to check their work. I'm just super, I always double, triple check things. So that's correct. That's what you got too? Yeah. Anybody else ready for me to check?
Of course I know. I did the
Perfect.
math. So it means I'm right.
Math this and all this has to be right. Math this and all this has to be right.
Yeah. It is.
You didn't hear?
My math is right. Maybe my chemistry is perfect. But I can tell you. Put two things together.
All right, so I'm just going to go ahead and go over the answer. The traditional method, it should be solved. If you have an alternative method, if it's a written question by Cambridge, I do want to make a point here. On paper one, you don't have to show your work, right? For multiple choice, you don't. For written, you do. And they do give marks based on you following proper steps. So if your work is messy and the Cambridge examiner cannot read it, you may lose marks. Be careful. That's why I show you specifically how to do it with certain steps. As long as your reasoning makes sense and a Cambridge examiner can follow it, that's fine. But it has to be something that they can follow. All right, so here we go. We should have gotten that carbon is 29.7, hydrogen is 6.19, and lead is 64.11. Next thing, divide carbon by 12, hydrogen by 1, and lead by, I think it's 207.2, right? Yeah. So we get carbon is, hold on. Carbon is 2.475. Hydrogen is 6.19. And lead is 'So here's where you can actually, there's a couple different ways you can go about this. You can either look at the information they've given you to draw a conclusion, or you can just simply follow the steps through the rest of the way and divide everything by 0.309. If you do that, the number you're looking for is the one for hydrogen, right? So 6.19 divided by 0.309 gives you 20.0, or the answer being 20. You don't need everything else because it's already given. So if you got 20, that is the correct answer.
That's perfect.
So notice, I didn't write that much work. I wrote dividing by the molar mass, and then I wrote dividing by the smallest number. If you write that, that's enough. Yes.
It's only 64.
So you can estimate it if you want.
I just did.
You can estimate it if you want. Somebody else is suggesting the same thing. However, if it was a paper 2 question, they would be looking for these steps. If it was a paper 2 question or written question. So for paper 1, sure. For paper 2, you should write the steps. All right, so we're gonna go ahead and continue. We have now went over empirical formulas and how to calculate them, but we also need to look at molecular formulas. So remember the difference between an empirical formula and a molecular formula is the empirical is the simplest version of the formula that holds these mass percents, but it may not actually describe the molecule we're working with. And so if we're looking for a molecular formula, we're going to need an additional piece of information. And so the extra piece of information you need to find the the molecular formula is you would need the MR. They would need to give you the molar mass of the molecule.
Students, we're in a lockdown drill. Make sure your doors are locked, the lights are off, and get out of any visible light. Thank you. Teachers and students, at this time the lockdown has been lifted. Thank you for your cooperation.
the molar mass was actually 88. Could you figure out what this molecule actually is? How would you do it?
Find the molar mass of CO2.
And compare. Perfect. So the idea is that if you've got the molar mass given to you of the molecule, and you've got the empirical formula, well, you can figure out the mass of the empirical formula because you know that that's 1 carbon for 2 oxygens. So you would say, okay, well, I know that this is 12 plus 32 is 44. And that CO2's molar mass is 44. The molecule I'm looking for is 88. So the molecular formula, it's important to note, is always a multiple. It's either equal to or a multiple of the empirical formula. So you may want to write that down. The molecular formula is the same or a multiple of the empirical formula. So then, in the example I just quickly wrote up, what would the molecular formula be?
204.
Perfect. That was quick, right? So you would know to take 88, divide by 44, always bigger number divided by smaller number, right? Whole number would be 2. And then this would tell you what you have to multiply each of the amounts of the empirical formula by. So it would be C1O2, multiply each of those by 2, and you get C2O4. So that's how you're going to go from empirical formula to the actual formula of the molecule, which we call the molecular formula. What actually exists. All right. So we'll do that again in a moment. I just wanted to give you an idea of what it is before we go do it. And so it's really, if you know the empirical formula, it's not a complicated process. It's just get the molar mass of the empirical formula versus the molar mass of the molecular formula, divide the two, and that tells you what you have to do. So I'm going to be quick here. Check up 10. The empirical formulae and molar masses of these compounds are shown. Can you figure out the molecular formula for compound A, compound B, and compound C? And I've given you some space to solve. What would we do for compound A? Now that I've shown you one time. Get the molar mass of C3H5. So what is the MR of that? It's going to be 3 times 12 and 5 times 1. Add those together, you get, I heard it, 41. The molar mass of the molecule is what? 82. So now, in order to get the formula, we would take 82 divide by 41. That gives us the number 2. This is what we multiply the amounts by. So now go back to C3H5. We multiply each of the amounts by 2, and what does that give us for a molecular formula? Multiply by 2, multiply by 2, you get C6H10. So the actual molecule is C6H10. Okay with this? Compound B. What's the molar mass of that empirical formula? 12 plus 3 times 35.5. And that's 118.5. MR is 118.5. Molar mass of the entire molecule is 237. So what do I do now?
37 divided by 118.5.
Again, that should be 2. And so we multiply the subscripts here by 2. So it would be C1, Cl3, multiply both by 2, and you get C2, Cl6. Good with that? CH2. What's the molar mass of this empirical formula? Okay, so 14 is the empirical formula's molar mass. Our actual molecule is 112. So now what do we do? Equal to 8. And then we would do C1H2 multiplied by 8. And that gives us C8H16. By the way, this is an alkene. This is the empirical formula for an alkene, C1H2. Alkene. That means that this has a double bond. CnH2n describes an alkene. That's an organic thing, meaning that you got a double bond there, right? So we can actually look at an empirical formula. It can actually describe to us what type of compound we have. I know C8H16 is most likely an alkene. If I were to draw it out, there should be a double bond somewhere in order for this to work out. If it was an alkene, it would be C8H18. But that's a discussion for another unit, right? Just bringing it up. All right, so we can do this. We're okay with comparing the empirical formula to the molecular formula?
Yes.
All right. So that is what we were supposed to finish last class, actually. But due to PSAT testing, we didn't. So now what we have to do is move forward. Because like I said, I want to do a lab next class. So I'm actually doing half of the lesson today and half of the lesson next class. And then the second half of the class, we're doing the lab. So the other part of today should be largely a review. Do you remember how to get ionic compound formulas if given the charges of the elements? So for example, if you are given Fe plus 3 and Cl minus 1, can you figure out what the ionic compound's formula would be? Perfect. You just have to remember we use something called the crisscross strategy, and we would need to know that overall ionic compounds have to be neutral. Do you agree? That if whatever the amount of positive charges I have has to be the same as the amount of negative charges. So this should be FeCl3. How will you know if you have a transition metal if you've got iron plus 2 or iron plus 3? How would you know? Because remember, transition metals can have different numbers.
The other element?
The other element can help you with that, absolutely. That's one way. Another way is they would give you a Roman numeral, and you're supposed to remember that that Roman numeral is equivalent to the charge of the metal they're talking about. So if I see iron 3 sulfate, that means I'm talking about Fe with what charge? And if I saw iron 2 sulfate, that means I would have iron with what charge? Plus 2. These charges go by another name. They're actually also called the oxidation state. So you may see this in questions. When you are told the oxidation state, and you've got an ionic compound, it's going to equal the charge. So it could either be called the charge, but it will more likely by Cambridge be called the oxidation state. So redox is coming. We're not at that lesson yet, but it's coming. Because these are the same, these charges are the same as their oxidation number. So notice what it says here. You're not responsible, so this on purpose. You do not have to memorize every single possible charge a transition metal has. I do not need you to memorize iron is plus 2 plus 3, copper is plus 1 plus 2. I don't need you to memorize that. I just need you to be able to look at this and see, iron 3 plus 3. If you have something you don't know the charge of, you would get it by looking at the Roman numeral. That's what you've got to know. We're good with that? How do we know if an element has a variable charge in the first place, or if it has a fixed charge? Go ahead, Justin. Transition metals. Is there one here? No, not that. Like in your lesson. I think no, right? It's not on there. Here's a periodic table. Let's go ahead and fill out something real quick. I got extras from previous chemistry. Remember I told you they were coloring? We're not coloring. But we need to remember something. So here's the periodic table. I'm going to pull up one since I don't have it in the notes, but I have one written out. This is the Cambridge periodic table. You've gotten this before, I believe, but here's a copy. You're going to need to fill out a couple things here. Oh yeah, thanks for reminding me. As soon as I finish that job, on my right now. You can grab the pass. Table. Okay. You may have filled this out before. If so, I don't care. You should fill it out again. Because it's that important for you to know. Yes. When the person who just logged out gets back. All right. So I'm exiting out of here real quick just to pull up the periodic table. Okay. How do I know if my element has a fixed charge or a variable charge? Everything in group 1 has a fixed charge of +1, which forms an ion. This has got to be stuff that's drilled in our heads, like it's second nature to us. Everything in group 2 is +2. Everything in group 3. And then group 14 is weird. It could be plus or minus. Group 15. -2, -1. All right, that covers a lot. But did you know there's other elements you should know the charge of by heart? What are the other ones? Zinc was mentioned actually in the standards, wasn't it? There were 2 that were specifically shouted out. Zinc, you should write in your periodic table, has a charge always of +2. So if they tell you zinc chloride, what that means is they're not giving you a Roman numeral with it. That's what it means to you. Because they're assuming you know that that's +2. So you won't ever see zinc 2 chloride. You'll just see zinc chloride. So if I didn't tell you that, you might be like, oh, this is the middle. It's a transition metal. But actually, it's got a fixed charge. What are the other ones that have a fixed charge? Silver is shouted out in standards too, right? And there was one other that we should also be aware of. It's cadmium. Silver, zinc, and cadmium, although they are in the transition metal section of the periodic table, actually have fixed charges. If you were told silver nitrate, they will not put a Roman numeral. They are going to expect you to know what that formula is by heart. Silver nitrate, AgNO3. We'll see it short. But I'm just bringing it up that this is really important because this is how it's going to be communicated to you for those specific elements. We're good with that? Do we ever look at these ones down here? Can it even test these? They're like, well, these don't exist. They do exist, but like, I mean, they do exist. Most of them are radioactive, but most of what we're going to do is going to be within here. Okay? Yeah. We come up to them when we come up to them. We're good here now. All right, where am I going back to? I'm going back to here. So we were here. We are now here. I know you're so excited. It is time. Whether you use flashcards, whatever memorization techniques you use, you need to memorize these polyatomic ions by heart. You should check through the list, check mark and X the ones you already know by heart and the ones you need to work on. Do you know ammonium by heart? You should, because I told you to know it for unit 2. NH4+, we know that? Carbonate, CO3 2-, yeah, because we drilled it though. Hydrogen carbonate might be new. HCO3-. Hydroxide we've seen a lot because it's base. OH-. Nitrate, phosphate, sulfate. I would say these last 2 are probably new for all of us for the most part. You should know permanganate and you should know dichromate. Those are the 2 that weren't mentioned in the standards today, but I guarantee you're going to see them very shortly because they're in organic chemistry, the organic chemistry part of the class, and they are both used for oxidizing. And redox is in this unit. So even though they didn't show up in the first learning objectives, you need to memorize these two by heart as well. Another way that this can show up, it has a different name, but besides permanganate, you should write it down because the other name shows up a lot on Cambridge questions. It's also called manganate 7. Manganate 7. I'm bringing this up because I've read thousands of Cambridge questions. Go ahead, Julio. Go. Why should we call this manganate 7? Anybody got a good guess? Go ahead. Are you next to the bathroom? Because what? Charge of what? That's absolutely correct. The reason why it's called manganate 7 is because if you were to work out the oxidation numbers, the oxidation number of manganese here would be +7. We're not going to do that today, but that is where that name comes from. So it has that name for a reason. You should write it down because it will show up in questions. So when you memorize it both ways. In our American labels, we use permanganate. This is what Cambridge will use, manganate 7, for that specific one. You can see it's the only one manganese, so it's kind of easy to remember at least this way. MN, manganese, manganese. All right, memorize. That's your weekend goal. If you haven't memorized these already, to go ahead, memorize your polyatomic ions by heart. This leads us to naming. Hopefully this is review for most of us. To name binary ionic compounds, all you gotta do is give the name of each element, and the second element you change the ending to?
ID.
So that's always the non-metal, right? Non-metal ending changes to IDE. So chlorine becomes chloride. If you get an H or an ite ending, this means you have a polyatomic ion. There are a few exceptions. Hydroxide. Hydroxide is polyatomic ion as well. And that's just one you gotta know by heart. Let's see if you can write down the formula for each of these. Magnesium nitrate. What will we do? What's the first step?
MG.
Mg. And what do we gotta find with Mg? It's charge.
So
What's the charge of magnesium?
positive.
Positive. Nitrate. Do you have it memorized or not?
NO3.
NO3.
-1
-1. All right. Something that you must remember when you have polyatomic ions, if you have more than one of them, what should you do?
Write it in parentheses and connect it to outside the premise.
Right. So if you're going to have more than one of a polyatomic ion, you need to remember to put parentheses around the polyatomic ion. And so we're going to crisscross. And we get Mg1, NO3, 2. Calcium sulfate, second one. Calcium has what charge? Sulfate has what polyatomic ion?
SO3.
Not SO3, it's sulfate. SO4. Do you remember the trick to remember if it's 3 or 4 oxygens? I might have given you a trick with the periodic table for what it is. Let's go back to your periodic table. I'm going to keep this real quick. Head back to that periodic table. Do you remember that I had you write a 4?
Yeah.
You may want to fill that in that periodic table. That tells you the 8 ions that have 4 oxygens. Four oxygen atoms. Really, for us, it just means phosphate and sulfate have 4, and everything else has 3. That's all we need to know. Phosphate, sulfate have 4, the other ones have 3, like chlorate and carbonate and nitrate. Out of the main ones we need to know. You remember that 4? Ring a bell? I had you mark up like 10 periodic tables. So if you don't remember, I don't fault you. But we did do that. That told us, this 4 right here told us that those polyatomic ions when they ended with ATE that had 4 oxygen atoms. With phosphate had 4, yes. No. You can be in line for the bathroom. There's one person before. Keep in track, Julio, David, Rosalind. lie. All right, going back to the lesson. So now that I've said that, what's sulfate? SO4 with what charge? -2. What is the actual compound for this? They cancel, right? If it's 1-to-1, they just cancel because we want the simplest ratio. So it's CaSO4. Good so far? You ring a bell? You don't need to if there's only one. You can if you want. If they won't count it wrong. It's just unnecessary. Hydrogen bromide. What's that? What's that? Is it? H has what charge? It's an acid. +1. Bromine? 1-to-1, right? It's just HBr. What you did was you did the standard state of bromine, which is Br2. But you don't need the standard state of bromine for this. Ammonium sulfide. All right. Make sure to knock. Alina? Ammonium is what? Got that memorized. Hopefully. And sulfur? Sulfide. Sulfide. S? If there's more than one. Will ammonium have more than one? Crisscross? NH4? 2? X. 1. Do you have to write the one at the bottom for sulfur? No. Do you have to write NH4 in parentheses? Yes, because there's more than one. And so that's ammonium sulfide. Cambridge will expect that you can write ionic compound formulas correctly. On top of that, oftentimes, you are given compounds by name and not by formula. So you're going to have to work with compounds by name and you write out the formula when you're working on questions. So make sure that you review this. I will give you some practice problem sets on this as well. Some pre-ACE level ones so that you get additional practice with this. Let me know when you got it. We're going to go the other way around. Some of you may be ahead of me and you may have already done it. All right, so the other way around. I give you the formula. You give the name. What's the name of the first one? What do we do?
Sodium phosphate.
Sodium is the positive ion. So we name the positive ion and then we name the negative ion. So there's always going to be two names. Sodium and then PO4 is phosphate. And you know that because this is a polyatomic ion that has to be memorized. Because it's on the chart, right? NH42SO4, what's that? That should be an S. No, just S. It's sulfide. IDE ending means it's just the element. NH42, what's that? So this is a positive ion, that's ammonium. And the negative ion here is that SO4, what's that?
Sulfide. Sulfate.
Sulfate. You don't even need to know sulfide. You only need to know the 8 ions. Sulfate. 8LCl3. Does that have a polyatomic ion?
No.
No.
Aluminum. What?
Aluminum or aluminium, either spelling is fine. Aluminium, and this will be chloride. Do I need a Roman numeral? Yes or no? No, because aluminum has a fixed charge. CaNO3 too, what's that? Calcium. That's the positive ion, and the negative ion is nitrate. ATE. NO3 minus is ATE. Nitrate.
What is the difference between nitrate and nitrate?
Nitrite would have one less oxygen, but Cambridge doesn't actually even use that terminology. America does. They would, Cambridge will talk about when we look at oxidation numbers, nitrate and nitrite would have different oxidation numbers for nitrogen. All right, next thing, state symbols. This is going to lead us to our last topic of the day. The last topic of the day is going to be balancing equations. That good old review of balancing equations. So before that, looking at chemical reactions, you've got to know states of matter. S stands for solid, L stands for, G stands for, and AQ means, which means that whatever I have is
And water.
dissolved in water. So you should write that as a note for yourself. Is water aqueous? Water is not aqueous. Water is not dissolved in water. Water is water. Water is liquid, and you should know that. Water itself is liquid. What we dissolve in water would be aqueous. So for example, if I put salt in water and I mix it up, that would be an aqueous solution. Water itself is not a solution, it's just a liquid. Okay? Yes? Right? It actually looks something like this. NaCl plus aqueous, meaning water gets put into it, is NaCl aqueous. But what really happens is you would have Na plus ions in water and Cl minus ions in water. This is what's going on. So we typically write, this will be for another lesson another day, but we typically write the positive ion in water and the negative ion in water. It's called dissociation. So you're never going to see this in AS chemistry. It's not going to be written like this. What you will see, though, is this. If I have NaClAq, that means that I have Na plus 1 and Cl minus. And they're both aqueous in water. That you will see as an equation. It's called ionization or dissociation. We're going to see it later. Later, not yet, not today. But you asked the question. So. Standard states, the other homework you have for this weekend. Because we're going to be completing and balancing equations next week. You've got to memorize standard states. Like Rosalind, you had done earlier for the BR2. This is where that's at. This is how elements naturally exist. Cambridge expects you to know when you are completing reactions how elements naturally exist. You have to know if your element is monatomic, diatomic, or polyatomic, and you have to know if it's a solid, a liquid, or a gas. This periodic table in the front actually has a lot of that here. The elements in red are gases, the blue are liquid, and the black are solids. Almost all your elements on the periodic table are solids, and almost all the elements on your periodic table are monatomic. What does monatomic mean?
One, but
This is one. So for example, Na solid has a 1. Do we write the 1?
no.
No. But that's what a monatomic solid is. That's what we mean by monatomic. Means it exists as 1. And so you have to memorize, and this is going to be the first time, not the last time I ask you this year, because you're going to need it for multiple things. The first thing you're going to need standard states for is completing and balancing reactions. Because guess what? We're going back to how do we complete a single replacement reaction? How do we complete a double replacement reaction? That's coming next week. We are going there. And so you've got to memorize your standard states, because when elements are made, they're made in their standard states. And so this is on your homework. Memorize this if you haven't already, or re-memorize it. Go back over it for next week. This is another look at it. This is how I printed it in Crease, and I gave it as a handout. I'm sure I printed this out and gave this as one of your handouts in Crease chemistry. This is another way of looking at your standard states. You can also take a picture of that periodic table in the front because it has them all there for the states of matter. You just then would have to memorize your diatomics, monatomics, and polyatomics. Do you remember how to quickly look for your diatomic elements before we balance equations?
7.
This 7 right here are all your elements that exist as 2. There are only 2 polyatomic elements that exist, and we studied them in Unit 2. So I gave you a heads up. What are the 2 elements? P4 and S8. So, except for these and hydrogen. Hydrogen is also H2. Every other element exists as 1. Every other one. So we've already actually done a little bit of this legwork last unit because I taught you the 2 polyatomic elements, and then these 7 are diatomic along with hydrogen. All right, last thing, practicing, and this year we go super quick with balancing equations. You are expected to know prior to this course how to balance equations. So we're going to quickly review it. Balancing equations has to do with the law of conservation of mass. What does that mean? The amount of your reactants have to equal the amount of your products. So when we're balancing equations, we always try to figure out what numbers we have to place in front of elements in compounds. We call these coefficients. You may want to write that out. It's the same thing as math. We can only balance coefficients. We can never change anything else except for the coefficients. So whatever the identity of the reactants are, whatever the identity of the products are, they stay the same. And you can only change the numbers in front when you're balancing an equation. So we're going to go back over that process now before we read for the day. And like I said, we got through half of the lesson today, and then the other half we're doing next class. Going into the lab, that'll be the second half of next class. Reminding you of balancing equations. By the way, the first half of next class is completing reactions. Because we're going to do a reaction as a lab, so we have to complete reactions first. All right, how to balance an equation. The first thing you should do is count up how many atoms you have of each element. Last year, what I did was I gave or the year before, and if you never had me, then you're going to stay for the first time. I would write out like a list of how many I had of each element, and then I would start changing the numbers until you would make them the same. So I listed it as a chart. You don't have to make a chart. It's just a strategy to help. In order to balance equations, what you have to do is you have to make the amount of elements the same on each side. So if I have 3 sodiums on one side, I have to have 3 sodiums on the other side. You've got to make the amounts the same. Now I put some notes here to help with balancing. The first one is you always want to make the side with the smaller amount equal to the side with the larger amount. We change smaller numbers to become equal to larger numbers. It is best to try not to do everything at once, to balance just one element at a time. If you see an element on one side of the chemical reaction that appears more than once, save it for last. That's going to be oxygen and combustion reactions, just as a note. You may want to write that. That's a very famous one. And if you don't remember what a combustion reaction is, don't worry, it's coming. And then if you see the same polyatomic ion on both sides of the reaction, like nitrate on the reactant side, nitrate on the product side, it is usually best to just try to balance that polyatomic ion together and not split it up into the individual elements. So these are the guidelines of balancing equations. But the best way to do this is to practice, to take a look at what did we do for this, how do we do this. And so I'm pausing for a minute just to give you some time to write this, and then we're going to move forward. And the last set of questions is just practice questions with balancing. This is the way Cambridge asks the questions. So it's the textbook question, but it's also how I see Cambridge present them in paper 2 questions. Write balanced equations for the following reaction. Iron reacts with hydrochloric acid to form iron 2 chloride and hydrogen. So what will we do first?
Write the reactant.
We're going to have to figure, what is this called? This is called a word equation, right? Word equation. Reactants, and we're going to need to identify what are our products. What are our reactants?
Iron and acid?
How do I know how many irons I have in iron? How does iron exist? Well, it's a metal. Metals are monatomic. All metals are monatomic. So iron exists as one, yes? Okay. It reacts with hydrochloric acid. Do you know what hydrochloric acid is? It is assumed you know this. It is HCl, in case you don't. Hydrochloric acid is HCl. In a lesson very soon, I'm going to go over the 3 acids you have to memorize by heart, HCl. Okay, what are my products? They were like, here, we're going to just tell you it's FeCl2, iron 2 chloride, but you could have figured that out. FeCl2, and what's the other product?
H2.
Plus hydrogen. How do I know how hydrogen exists?
It's that.
Diatomic, right? And you've got to memorize that hydrogen is one of your diatomic elements. It's the 7 and hydrogen. So what is this called right now? Have I balanced this equation?
No.
I would have called this before the skeleton equation. It's just the overall reactants and products, but we don't have the correct amounts. You'll notice in this class, balancing is usually pretty easy. Meaning you're not going to get as crazy of numbers for the most part that you even got in a previous chemistry class. Go ahead.
Don't you just need to put 2 in?
That's what I meant. The balancing is usually not crazy. Notice you've got 2 chlorines on the product side and 2 hydrogens on the product side. What number would I need to put in front of HCl to make the amounts the same on both sides?
2.
That's already answered. It was 2. That's it. That's all you got to do here. If the pass, Rosalind's not back quite yet, so when she goes back. Okay, so what are all the other numbers? It's balanced with this. What are all the other numbers?
1.
Do I have to put 1?
No.
You know, but you can if you like. That's it. It's a balanced equation. Because the amount of atoms on the reactant side are equal to the amount of atoms on the product side. Do you have to write a chart to say how many you have? No. When would we do it? If it's complicated. Like if I need to reason it out, maybe I would. But you don't have to for the question. Let's try another one. Aluminium hydroxide decomposes to form aluminium oxide and water. So, reactant, they told it to us. AlOH3. And my products are Al2O3 and H2O. What can we do here? Remember, you can only change the numbers in front. What would you want to change first?
L.
And why? That is correct. I would want to change aluminum first. Why?
Because it's the easy.
Why is it the easiest? I'm going to explore that a little bit more.
Because it's single out.
And when it was alone, it just worked. So.
Because I see oxygen in 2 places here. I know that I don't want to start with that. If you start with something that occurs in more than one place on one side of the reaction, you may end up with circular reasoning, and you could get numbers, depending on the question, in the hundreds, and never come up with an answer. I've had students just spend 30 minutes, an hour, 2 hours trying to balance one equation because they started in the wrong spot. Starting with aluminum is a good idea. All right, so, by the way, if you ever find a chemistry question taking you hours to solve, you should probably just text me. On talking points or email me. You should never be spending hours on a question. Please don't do that to yourself mentally. Okay, next.
What is that side of the equation?
So when I put a 2 here, I put a 2 there, right?
Yes, and when you're on H2O,
So right here I will have
2
6 hydrogens, 2 aluminums, and how many oxygens? 6. So you suggest putting what number in front of here?
3.
3.
That's off there.
Is everybody okay with this? 2 times 3 is 6 hydrogen. So after I fix the aluminum, I fix the hydrogen. 3 times 2 is 6. And then for oxygen, is that balanced?
Yes.
You've got 3 oxygens here that you're going to add with 3 times 1, which is 3 oxygens there, and that's also 6. So this number in front here would be a 1, which you don't have to write. Yes? Make sense? Familiar. Something we're familiar with? Remember, the main goal here when you're balancing equations, you're making the amount of atoms on the left side of the reaction the same as the amount of atoms on the right side of the reaction. You have to change the numbers in front. We call these coefficients in order to do that. And the numbers that you get in this class are usually not going to be crazy. The craziest numbers you're going to get are in 2 types of reactions. One of them is called combustion. Combustion will give you numbers that you could get past 10. Oh, look! Combustion! So, ready for the next one? No. Do you need more time or just medicine? Hexane burns in oxygen to form carbon dioxide and water. Let's write this one out. C6H14 burns in oxygen. What is oxygen?
O2.
Plus O2 makes carbon dioxide and water. This is combustion. So, what element would I not want to balance first?
Oxygen.
Save oxygen for last. Yes? So what we can start with either element. I usually start with carbon. I usually just go in that order. Cho. Carbon. 6 on the left side. So what number do I want to put in front of CO2? 6. Correct. Because 6 times 1 is 6. Let's do hydrogen next, right? 14 hydrogens on the left. What number do I put in front of water to get 14 hydrogens on the right? 7. Now, figure out your oxygen. You've got 6 times 2 here. How many oxygens is that? 12. You've got 7 times 1. How many oxygens is that? 7. So the question is, how do I change 2 oxygens into 19? So there's 2 ways you can do this. You need to make 2 equal to 19 by multiplying by something. Are you allowed to multiply by decimals? Yes, you are. You would never have to multiply by decimal other than 0.5 actually. So you could write 9.5 if you knew that, which is taking 19 and dividing it by 2. Or you could double everything and get 2C6H14 plus, that would be 19 O2s, goes to 12 CO2s plus 14 H2Os. Cambridge not only allows this answer,
Good afternoon, Golden Lions.
They
This is
encourage
Devin,
it.
and these are your afternoon announcements.
We
Students,
checked.
please remember
I
to check
think we
your
pretty
Cambridge
much
email daily
finished.
and report to school's proper CIE uniform. Make sure your outerwear is solid white, black, or red. Also, please wear your student ID badge around your neck at all times. Pensions will be issued to students who have not adhered to the uniform policy. Please remember you must wear your student ID every day.
All right, last 3 questions. Try on your own. I'll stamp it if you got them right. We've done enough. Last 3 questions on your own.
Get a slot in the end of your site fund. Go to www.yearbookorders.com. Order number is 21022. I'll be wrapping that away with a jean. You can wear any color jeans and participate in another. Please make sure
I'm also passing out homework.
make sure
The
your
first
jeans
written
do not
homework
have
this unit, right?
Now I missed it.
no CIE featuring that wiggle. Attention students, Mu Alpha Theta will be meeting on today after school in Ms. Morales' classroom. Attention students, I believe will be at CIE on Friday, October 13th. They will be selling uniforms during lunch. Only credit cards will be accepted as payment. You can also purchase uniforms online at www.ibleed.com. Select Center for International Education, the uniform piece is available.
Students, please be advised, detention is today in Mr. Werowitz' room. We have 11 students that are supposed to be serving this afternoon. You need to check your Hero app. If you do not serve, that will be doubled. If you do not serve, that will be doubled. Good afternoon, series students. This is Ms. Garcia. In honor of World Mental Health Day, tomorrow you are allowed to wear a green shirt. If you are paying the dollar, you can wear jeans tomorrow for United Way. But to wear a green shirt, you don't have to pay $1, but you have to wear your uniform bottoms. So if you are paying the dollar, you can wear a green shirt and jeans. If you are not paying $1, you can only wear the green shirt. Homecoming tickets are on sale until Sunday. Again, homecoming tickets are on sale until Sunday. There will not be any exception. You cannot come and say you missed the date. So listen again, homecoming tickets will be on sale only until Sunday. In honor of World Mental Health Day tomorrow, we will also be, the Mental Health Wellness Club will be handing out little green ribbons at the door tomorrow morning. Enjoy your day, CIE.
It's the ACL too, because half of the questions are. All right, remember, if you are done with those last 3 questions, raise your hand, I'll check them and stamp them if they're correct. If not, have me stamp it at the beginning of next class. I have passed out the homework. Did you get a copy of the homework? Oh, I do have it. It'll be posted online after school today. What do you need? Oh, okay. Include your stake symbols though. It tells you this is solid, this is nucleus. Let me check these. These are good. So I'm gonna stamp it, so make sure to put your stake. Hopefully most of this is review. Remember, the last 3 questions you're having me stamped. If you do not finish it by the end of class, you will show it to me during bell work time next class on Monday.
And the last part is
Oh, that's not a thing. And an A-board. And a charge your arm, it's not a thing. My bad. Instead of saying this, that's the camera examiner will say. Go past this. There you go. How much is that? I'll take it. Thank you, Ernesto. Alrighty, I will see you all until Monday, so have a wonderful weekend. Don't forget, bring a hair tie on Monday if you have shoulder length hair or longer. Yeah, like that's fine. Having your hair for that way, that's fine. Alright, have a wonderful afternoon. I will see you all Monday. I will not be on campus tomorrow, so see you all Monday. All right, let me turn the light on. Bye. It's for those who are helping out with spooky science. Yeah, so it's not for only those who are helping out with spooky science. On the 24th? That's your fault.
The environmental.
Yeah, many people show up.
I didn't know the first time.
Okay, I understand.
I have have like 4 meetings today.
Go to the meeting you have to go to.
There's a new alpha beta.
Go to the Alpha Theta because our official meeting isn't until the 18th. That's next Wednesday. So you're good. This is only a spooky science planning meeting. It's a specific meeting for a specific goal.
I was gonna sign up for it, but then I didn't even show up for the last one because I was sick. So
It's up to you. Go to the Blue Alpha Theta meeting. You should go to the Blue Alpha Theta meeting first. And if you want to come back, you can, but you don't have to.
I'll have time, sure.
Okay.
Bye, Miss.
Bye. Have a good day, Ben.
Have a good day. Bye.
Bye. Spooky Science Planning Meeting. Spooky Science Planning Meeting. If you're coming in for that, then you need to sign in the attendance sheet so that you can get your hours. Hi.
No, you're not here. You're going to environmental club in Alpha Theta, right?
Oh my God.
Alpha Theta.
All right, everybody who's helping with Spooky Science should be signing in so you get credited for the volunteer hour.
She'll sign it.
All right, so
Get ready to read.
do you?
You have to be ready to write all the questions.
I have a plan. No. Just prepare a table. Oh, you can have a calculator though if you want it. All right, sign in. Sign in if you were planning to help out with
Mr. S is.
Spooky Science.
Like, you're the same age as Mr. S now. There's no way.
What?
She's old now.
That's what's going on about that.
She's old now.
Well, so are you.
Huh? I'm not old.
Hurt. He doesn't even do anything. You do it. You just like we just punch each other's hands. All right, make sure you're signing in. Yeah. Which question?
Is that
Yeah.
okay?
That's right.
Alright. And then for these, it's supposed to be like that's how it's supposed to be written, right? Like that's. I just didn't know what it was like asking.
It's these elements. You arrange them. Which one has the smallest? Which one has the largest? And addition energy between CFO and then between KLI and S. You have to organize it. So the way you organize it is right.
All right, thank you. You're welcome.
All right, so this is a planning meeting for Spooky Science. Valence electron. After the valence electron is removed,
So then, electrical.
it would be the same as a noble gas. You're welcome. All right, so make sure you are signing in if you're here for the Spooky Science Planning meeting. I'm about to get started shortly. Yeah, I got the second one. The first one. Wait, no. Yeah, yeah. Look at it. This was so different. And then, what? There's 4 different colors. The 24th. I hate this. Look, I won't finish it though. Okay. So, we're going to go ahead and get started. The purpose of this meeting is to organize ourselves in terms of getting ready for Spooky Science. Spooky Science, as you may know, is October 24th after school from 2:30 to 3:15 p.m. for the different places where we'll be doing stations moving. and then we'll do a couple of demonstrations at the end. And so the 4 stations that I have in mind for this year, one of them we do every year, it's elephant toothpaste, because that's the one where you get a lot of foam, and it's a big exothermic reaction. It's pretty fun to do. And then this year, the selection is we're going to do spooky density columns. And so basically what that is students are going to create a jar. So you're going to get a jar, like a pasta jar, and you're going to put different liquids in that jar that have different densities. So it's going to make a variation of different colors. And then you're going to put food coloring that's red into water to make it like have the appearance of blood. And so you're going to have different layers of liquid, spooky liquid. Some will be black, some will be red. And then there will be different like spiders, not real spiders, plastic spiders, plastic eyeballs, a selection of little spooky things that you're going to drop into the density columns, and they'll fall into different layers. You'll have eyes in one layer, you'll have spiders in another layer. And so basically it's creating something, and they'll be able to take that home. Actually, so that's the spooky density columns. So that's a take-home thing. Last year we did a different take-home thing. I like to do something different each year so that if you're coming to Spooky Science each year, you're getting a different experience. The next thing, elephant toothpaste, you should already know that. If not, I do have the experimental guidelines for that, and you'll get that on the day for elephant toothpaste. Anybody who signs up for elephant toothpaste, please be aware, if you have a known iodine allergy, you should not sign up for that booth. So if you know you're allergic to iodine, do not sign up for elephant toothpaste because it does use iodine for the best reaction. I mean, there is an alternative, which is using yeast. Not as good. I'm just going to be honest with you. It's not as great of a reaction. So for the best reaction, we use iodine. But some people have allergies to iodine, so don't sign up for it if you know you have an allergy. So that's elephant toothpaste. Bouncy balls. This is a new one for this year. You're going to create a polymer, and then you're going to roll it into a bouncy ball. So you're going to make your own. You know how you buy them at the store? But you're going to make your own with science. Glue, cornstarches, a few other ingredients, and you can color it into different colors. If you use translucent glue, it'll be a colorless bouncy ball. And if you use regular glue, you can have like a marbled bouncy ball. And so that's bouncy balls. And so we'll need a few people to help out with that station as well. And I do have, like I said, experimental guidelines for these different experiments that we'll be doing. And then the final one that I wanted to talk about is a STEM challenge. And I have 2 ideas. So every Spooky Science, we like to do a station that's a STEM challenge. You get a certain amount of minutes to do a specific thing. One year we did building a bone bridge. And so there will be guidelines for that. And you have to hold, a bone bridge. It's not real bones. It's like, the things you put in your ears.
Oh, the Q-tips.
Yeah, Q-tips. And then you build a little, they look like bones. You build it, and then you see how much weight it can hold, pretty much. That was one we've done in the past. One that I found this year that was different was variation on paper airplanes, making bats out of paper bats. And then who could fly it the furthest, like down the hallway. And then there would be prizes for that. So the first question I had was, for the STEM challenge, which one would you be more interested in seeing or helping out with? Making a bone bridge or doing paper bats? We've never done the paper bats before. We have done the bone bridge before. What do you think? Anybody? It's open forum. Which one?
Paper bag.
Paper bats? Anybody else have any preference? Which one do you think would be more fun? No, that's my question is a STEM challenge. Which should we do as a school? Flying paper bats or bone bridge? Alex? You said bone bridge? You like the paper bats? All right, raise your hand if you think paper bats is better.
Wait. How would we?
Okay.
It should be just like.
I have them. Like, it's something that I have pre-created. You have to build the wings basically to fly it.
Oh yeah.
Is the idea. Okay, so we'll do paper bats. That's the one that will do that. All right. So the next thing to note, I'm going to request if on that day at 2 p.m. those who are helping out can be dismissed to this classroom to help set up the stations. So you'll be leaving your, I don't know, I think it's 6th period. You'll be leaving your sixth period a little bit early, unless you're in my sixth period. After you take the quarterly exam, you'll be setting up. They have their quarterly exam that day. So after the quarterly exam, you'll be setting up. It's a B day. It was a B day on purpose when I talked to, I have my smaller class on B day. My A day is 35 students. As those of you in my A day 5th period know, that class goes all the way to the back of the room. My B day 6th period is only 18 students. So we fill up only like the front part of the room. So because of that, we intentionally chose a B day to do this on so that we could set up the classroom. I couldn't set it up in 5th period. I literally would not be able to set up the room for spooky science on your class period. Impossible. What? Just kick everyone out. Just throw them in the media center. Bye. Goodbye, everyone. Anyway, we're not doing that because I believe in always teaching. So we're still going to be going. But it is for the B day, a day of a quarterly exam. So you'll take your quarterly exam and then you'll be helping them set up after that. Quarterly exam is not longer than an hour and 15 minutes because it's meant to mimic a Cambridge exam. It's the first quarterly mock exam.
What did I get on my first one? I think I got like I kept on getting C's. C, D, something like that.
They're reminiscing.
The highest I ever got was D.
All right, so now it is time. Let me see how many people. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we've got 13 people here, it looks like, and it is time to figure out who is doing what. So I know that there was a couple people who had signed up. Let me double check my board. Julio's doing bouncy balls, and Alina's doing elephant toothpaste.
I just gotta know something like that.
I need 3 people for each. 3 people for each. So let me ask Estella. You want to do the drawers? Yeah. Sure. All right. So Estella, Kiara, and Alex. You'll be setting up for the spooky density columns. I have to go out and buy the stuff for it. I haven't bought it yet, but at least, like I said, the purpose of today is figuring out what we're doing. I will have everything purchased and ready for that day when it's time, and you'll just have the instructions and you'll get the setup. Yes.
Can we do that bouncy balls?
You want to go through the bouncy balls? All right. So that's with Poppy and Samantha with the bouncy ball. All right, over here. Going into paper butts, okay? All right, so you 3 are going to be in charge of also doing the competition, meaning that whenever it's going to be 15 or like 10-minute rotations, they're going to go out into the hallway and they're going to each fly their bats and see which goes the farthest, and you're going to have to measure who went the farthest. Because we're going to give them away like either candy or Pokemon cards. Okay, yes. Elephant toothpaste? All right. Who's left? Who still needs to participate? Officers, you can command a booth or you can take on a demonstration.
Demonstration?
Yeah. So the demonstrations you can do are that haven't been spoken for. You could do the screaming gummy bear, or you could attempt to do the hellfire reaction. And let me see the last one. Oh, the last one's already somebody's doing it. So it's screaming gummy bear or hellfire reaction.
Hellfire reaction.
It'll make a volcano of fire. Is all I can say. That's safe. It's gonna be in a contained area. It's not gonna be like forever. Kevin, you said Kevin. Did Samantha tell you what happened yesterday? They got locked in the room. No, you guys. Like I asked them, you tell her what happened.
Oh yeah, we were stuck. We were so stuck. It's
They barely
a
escaped.
house.
Oh no! All right. You'll never forget it.
And like the random like laughing like outside. It was so scary.
All right, so Kristen, you said you would help out with the hellfire reaction. So we'll test that beforehand in period 1. We'll test the demonstrations beforehand. But yeah, I think that does it, right? Does everybody have a booth? Okay, so what's gonna happen is I will have all the materials there that day. I am going to call only you students out of class a little bit early, about 20 minutes early. I'll request for you to get out of class to come over here to 222 to set up. My 6th period will be here, but they'll also be helping with setup if they're done with their quarterly exam. Like I said, it's a smaller class. It's my ACE class. So should be fun. Remember what you've got? I think I have some copies of some of the experiments, so you can look them up. Who was bouncy ball again? All right, so here's a copy of it. Elephant toothpaste. Just to look at the instructions if you want to take a picture of it. Let me see if you took a right. You took a picture of it. You both took a picture. Those are the other one's the baby. Ooh, are you sharing?
Sorry, I was on my way to work. I forgot what we're eating today.
We are done.
Are you done? Fuck.
Yeah, we are done.
There was really one thing I think I wanted to do.
April.
Whatever.
Screaming gummy bear. Hayden, did you bring back information for me
No, I've been
on
trying to.
flame test?
I've been trying to do it on figure out how to do it to music. I got the colored fire.
You got colored fire?
I figured out how to color the fire, but I don't have anything on like how to get it to music. And I was waiting until I had everything before sending it to you.
Okay, send it to me when you got it, okay?
Okay.
So that's what I have you in mind for. I'm just waiting on you.
Yeah, I told him about the meeting because I knew he was interested in this.
Yeah. So write your name down so you get the credit. Hey, write your name down so you still get the credit for being here.
Sorry, I didn't know we had a
All right,
meeting today.
and
I thought it was
who's
next
doing
week.
paper bags? Take a picture of this. Just so you know what the.
No.
Did you get a picture of the
I told you I needed next week.
And then that's the help you really need instructions.
What do you think? Okay, we can play it again. That private policy. That's the only way to win.
That is it. Yeah. What do you need for it?
I was my buddy at Laura's group. I was already like past the bridge when you called me. Yeah. I was past the bridge.
Practicing how to teach them coding.
I can send you a video. I'll check. Bye. I can send you a video, probably principal tomorrow because I'm going to be in a meeting, to send you a video on how so that you can help instruct them on this.
I called because I was on my way back there.
Let me write that on my list of things to do. No problem. All right. Paperbacks. All right, we are set. Bye. Bye. I won't see you tomorrow. I'll see you next week. I'm out of the building tomorrow. Bye. Have a nice week. I'm working tomorrow. I'm just not working here. Bye.
It is Coffee's birthday.
All right, cool. Is it Toffee's birthday today? Is it your birthday?
Yeah.
Happy birthday. Do you want some Pokemon cards?
I do want a Pokemon card. Well, look at you're not getting anything. Buy your own, bro. You got a job.
There's 4 packs since it's your birthday.
4 packs. It's kind of mini.
I didn't get anything on my birthday. Damn.
Oh, she came to a meeting on her birthday. But that Raising Cane smells good. All right, no problem. Especially, I'm hungry right now, so I'm like, I gotta go eat. Every time I smell, can you send me who's doing what?
No.
Yeah, I got it.
No.
All right, perfect.
You gonna go to work?
Oh, and you've got the attendance? Can you make in your sheet like a roster of who's doing, because this is for saving for volunteer hours. So So we remember we need to write volunteer hours. once
Oh
we've
yeah,
done
she
the
did write
event.
down like who.
You guys was here?
Yeah, who's
Okay.
here.
Perfect. Awesome, April. You're an excellent secretary so far. You're doing an amazing job. Although you missed the activity yesterday. We had so much fun. More trauma. I don't know. The House of Entropy.
I really wanted to
write this book back. It was
all on the floor.
That was
I am
super
so
messy.
hungry.
It was super messy.
It was my goodness.
Bye. Bye, Miss Lee.
Bye, Miss Lee.
Bye. Hayden, don't forget to email me.
I'll remind them.
By like the end of next week.
Bye.
Bye.
I just came to find my brother, but I think
He just walked out. I told him it was only going to be like a 15-20 minute meeting. So
yeah,
they
I was
just,
at a meeting, so.
was it Mulatto?
Yeah.
How's that going? You guys got competitions?
Yeah, I think in November, so I'm gonna try that.
How did you take chemistry, by the way? Did you take it at a different school or did
Yeah,
you?
I took it in Corey.
Oh, okay.
I didn't really like chemistry too much, but my friends all told me, they were like, if you had taken chemistry here, you would have liked science. And I
You
was
might have liked it a little bit more, maybe.
Yeah.
I don't know. You gotta ask your brother, cause
Yeah, he likes it. He's always like, oh yeah, I got 100. Oh my god, I just finished my chemistry homework.
my husband's sister took chemistry at Coral Reef, and she told me it was like the worst experience of her life. She had a terrible teacher, and they had like a transfer person in the middle of the year, and like it was just a bad time.
It was terrible for me.
So I'm sorry to hear. It happens a lot.
Yeah, I still got B's. I got 2 B's. And
No,
like
that's not
2
good
A's,
though.
But
Like,
I was still so mad because those are the only 2 B's I have on my transfer.
really?
Yeah. I mean, there's something.
That's frustrating.
It is.
And whenever that happens, it makes you like not like
They
that.
were high